Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. You know, I'm going to do something a little bit different for Science on Friday today. I'm going to show you 3 cases of flat earth trickery and how you can figure out somebody's trying to fool you with a video. So, let's cue up the music, and then we're going to have a little visit with Nick from Phuket Word. We're going to see PBrane, and we're going to finish up with Rob Skiba and Skiba lensing. So I think you'll enjoy it. Now, when I first started in the flat earth in November of 2018, this video by Miles Davis was all the rage in the debunking community. And I thought it was just such an elegant proof of the spherical earth. I don't even know how they could possibly come back against it. So here's the setup. We have a camera height that is at 210 meters in Scotland. We've got this bridge over the Forth River, and the top of these towers is at the same height as the camera, 210 meters. Now the interesting thing is these hills in the background are more than 500 meters high. So how on earth, on a flat earth, could we possibly see these bridge towers above the level of the hills? Now let me show you why this is a major problem. Now here is my original experiment demonstrating this. I used a flat table and I used 3 AAA batteries that are all the same size. Now what I want to call your attention to is the fact that the camera is at the level of the top of these batteries, and the way that you can tell them is you see how they all line right up? Now notice when Phuket set up his lighters, he set the tops of the lighters equally to each other. So let's go see how he tried to disprove Miles Davis. See if you can pick out the trick that he used. So here's his show game. He's got the science book in the back for a prop, and he's got 3 lighters set up.
They all appear to be the same height. We go this way, and of course this one's very big now because it's very close. And this one's far away, so it seems smaller. And that one's even further away, so it seems even shorter. Yeah, and when we come around here like this, we can see a distinct difference. But when we lift the camera up and the camera's eye level is level with the top of the lighter or the imaginary mountain, then those mountains in the distance also appear to be the same height now. Below eye level, they appear to get shorter and shorter. This is being used as a way to claim that things in the distance appearing to get shorter are going down a curve. But sometimes what happens is someone says, well, that mountain in the distance is higher than the mountain in the foreground. Let's make this mountain, or lighter, higher than this one.
The front lighter is clearly lower than that back lighter, but when you bring it around like this due to perspective, doesn't it look as though that back lighter is below the front lighter? How on earth could this be? How could something taller appear to be lower? But it's not really the same test, is it? Let's go ahead and stop this for a minute. So we have the back lighter is clearly higher than the lighter behind me. Yet, when you look at it straight down the line, it appears as though the near lighter, which is the shorter lighter, is actually taller than the one that's sitting on the book. This is simple perspective. But what's missing? How many lighters did we start off with? How many batteries did I have? And how many points of reference did Miles Davis have? Let's count them off. He had the 210 meters where he had his camera. Off in the distance, he had the top of the bridges at 210 meters. And they were higher than the mountains in the far distance, which were over 500 meters. But we only have 2 lighters here. What happened to the third lighter? Let's see if we can figure that out. Let's back up a little bit. Okay, so here's the third lighter. Keep an eye on this last lighter here and see what he does with it. Watch this. There's the distraction. And he's putting the book down. Oh, where's that lighter going? Did you see how he tossed it in the back? And he took out the point of reference. Let's see what that would have looked like had he kept all three of them. Now here's what he's showing you. And here are the lines that he drew. But let's see what happens if he had had that third lighter in there. Uh-oh. Will you look at that? It's pretty obvious to see that the two in the front are at the same level. Now on a flat surface, that battery in the back would have been higher than that middle battery. But he took the middle battery out. But without that reference lighter in the middle, you couldn't see the fact that even though it looked smaller, that back battery or the back lighter was still higher than the front two. Now let's go on and see another set of trickery by PBrane. Now the issue with PBrane started with this photograph of Mount Rainier. This is also a proof that the Earth is spherical. Now this is Mount Rainier in Washington State. And as you see, the sun is setting, the clouds are lit up from underneath, and the shadow of the mountain peak is being cast on the cloud deck above the mountain. The only way that that is possible is if the sun is lower than the top of the mountain, and the shadow is being cast up. Now, he tried to do all sorts of things with perspective, and he did cartoons of me. I pointed out the fact that there's clearly a gap between the top of the mountains and the cloud deck above, yet the shadow is on the clouds above, and the clouds are underlit by the sun. Again, all perspective according to him. Now, the piece de resistance was an experiment that he claimed to have done, and that's this one right here. Now, he's got a light in his bathroom over here, and you can see the shadow of this curtain rod showing you where the light is. See that right there? So the light is over here, and he claimed that it was about 8 feet high. And he had this little disc, and he put his little cutout mountain under it, and showed that even though the light was well above the level of the disc, we got a shadow on the disc above because of perspective. But is this a real test? The one way that this could have happened naturally is he could have had that light shining on the floor and had reflected light coming up. And you can actually see some floorboards in this CD. It appears to be a mirror of some sort. So there may be some element of that. But he insisted it wasn't coming from the floor. He insisted that it was coming from perspective, even though the light was much higher than this disc. But I noticed something strange about it. Do you? Is this disc round or is it oval? So I did a little experiment myself. Let's have a look. So what I did was I set up a styrofoam disc on a couple of soda cans, and I put a light above it, off in the distance, and then I had a bullet sitting right here. Now you can see the light, which is above the disc, and there's no shadow on the bullet. So how did PBrane get a shadow on the bullet? Let's go see. Well, looky there. He did it. But how did he do it? He tilted the disc. So if the light was above the bullet and the disc was on top of the bullet, all he did was just tilt the disc up a little bit. And as a result, the bullet cast a shadow on the bottom of the tilted disc. And that's what we're seeing right here. Pretty slick, isn't it? And as you can see right here, this disc is tilted. It's not in line with the light coming back from this curtain rod, you know, the shadow being cast by this curtain rod. He tilted the disc back a little bit and caused the mountain to cast a shadow on the back end of the disc. Those are kind of amateurish. These are street magician types. Let's go on to my friend Rob Skiba, who presented this evidence at the Flat Earth International Conference in Dallas this year. I wonder if any of his audience saw what he did. Now, of course, this is the Willis Tower in Chicago, and you can see it over the horizon, which is very clear. This is not very distorted. And I want you to see these top antennae. this part of the top of the building and then this shoulder. And notice that right here, perhaps, there may be another building. So let's go ahead and have a look at the Willis Tower from the same angle. So we see the antennas, we see the top part, and we see these shoulders, and we see maybe the top of this building right here, right on the horizon. Where's the rest of the building there, Rob? Let's see what his excuse is. Now, first, he claims that there are trillions of water droplets in the air, and they somehow combine to form a giant convex lens. Now, when there are trillions of water droplets in the air, we call that fog. And as a result of scattering of light from these water droplets, everything whites out, and that's why you can't see through fog, and it appears to be white in sunlight. But that doesn't stop him. We need to put a magnifying glass in the atmosphere. Now, I want to draw your attention to something. Notice that the lens of this magnifying glass is halfway under the table, and we're only seeing the top of the magnifying glass. Now, the center of the magnifying glass is where light goes through it straight. Now, at the edges, the light bends in to meet that straight light going through the center of the magnifying glass at the focal point. By putting the top half of this magnifying glass above the table and then using it to bend the light down slightly, you can see over the horizon, and that's what the meteorologist was demonstrating here, how the refraction of the light allowed you to see just over the curve of the Earth. But let's see what Rob did with that.
Guys, these are people who believe in the globe now. They are the ones that said, hey, the atmosphere really is acting like a lens, and they put a lens in front of the camera to show how it works. So I'm just doing what they're doing, using the sheet right here.
Now, I want you to see what his setup is. Now, in the back here, he's got a picture of the skyline of Chicago. And then there is a gap here. And then he's got a Fresnel lens. Now, you recall that when the meteorologist was using the magnifying glass to look over the curve of the Earth, one of the things that they did was they just used the top of the magnifying glass. And what happens is, as you bring it up, see how it raises the image on the other side? Look at that. Now, what Rob used was a Fresnel lens like this one. It too has a center. Like with all magicians, the setup seems to be at random, but it's very precise. He's taking advantage of certain aspects of this Fresnel lens. Both the photograph and the lens are sitting flat on the table. That photograph only goes up to about the center of the Fresnel lens. Now let's bring this up to about the level of the camera. And I'm going to go ahead and just put my finger on the center of this Fresnel lens. Let's see what happens when I move my finger back. See how it goes down? Now, instead of being at the center, let's go ahead and put my finger up here by the top and move it back. My goodness, the top of my finger has gone below the curve of the Earth. Let's go ahead and see this in a video.
Here's the first test of a sun moving over a flat surface, and with no atmospheric magnification, it does what we might expect it would. It gets smaller as it goes away from us. All right, now let's see what happens when we add in our atmospheric magnification. Again, water and refraction. Water causes...
Now he took this sun, which is centered in the middle of the Fresnel lens. He moved it back without the lens to show you what perspective does. Now he's putting the lens up. Remember, the center of the lens is at that level of the sun. We're looking through the bottom half of the lens. Let's see what he does.
This is magnification and refraction, right? So let's bring the sun back. Oh, check this out. Refraction bends the light downward.
Now, even though Rob hasn't done anything to prove that lensing is actually occurring in the atmosphere, he's making it a given that it is. He's putting up a lens in a very specific arrangement. and he's showing you the sun going down simply by moving it a little bit away from the lens. And what he's doing is he's trying to say that this is the reason the sun appears to go down. But notice he doesn't even take it all the way down below the bottom of the lens yet. It doesn't set. It doesn't go below the curve of the Earth. It doesn't get dark out. Now, once again, notice his arrangement. He's got a relatively low sun up there, which goes to the midpoint of this lens, which is sitting on the table. So again, he's taking advantage of the midpoint and the bottom half of the lens. Let's do a few experiments and see what difference this makes. Okay, so we have my son's Pinewood Derby car here. Notice that the little man is 3/4 of the way back from the front bumper. And what we're going to do is we're going to line this up with the front bumper right at the edge of this little box that I've got it on. And then we're going to adjust the camera so it is at the level of the bottom of the tires. And you can see it is right at the level of the bottom of the tires because the rear tires are directly behind the front tires. Now, let's bring in our Fresnel lens and see what happens when we look at the car through the bottom side of the Fresnel lens. Where's the man? Oh, there he is. You see how it shifted downward? Let's continue. Now here we're back with the tires lined up again because we're looking through the center of the lens and the distortion is minimal. Now let's go to the top part. Look at the rear of the car come up. Notice that the further away from the lens the car is, the more the effect. So the back of the car has much more of an effect than the front of the car. This is why Skiba put his photograph of Chicago 4 or 5 inches behind the lens because he wanted to maximize this effect. He also used a 2-dimensional object so you wouldn't notice this. Now let's go side to side. Look at the back end of the car come around as we come over to that side of the Fresnel lens. Now we'll go to the opposite side. You see the back side of the car come around? Look, you can see almost the side of the man as well. Now, just so you know that nothing was changed with the camera or the car, there it is. Now, I want you to tell me with a straight face that Rob Skiba wasn't aware of this effect and didn't use it to his advantage to try and support his flat Earth narrative. Now, let's quickly sum this up. Rob saw the very top of the Willis Tower across Lake Michigan from less than 40 miles away. This is exactly how much of the Willis Tower we expected to see from that distance on the Earth Curve calculator. Recall that we're just looking at the very top part of the Willis Tower. It's kind of questionable as to whether or not this building is even above the horizon, and that is exactly how much we should see. We should see the top third of the building, and we do. Now, let's look at this photograph right here. This is the famous Norwicki photograph from Warren Dunes at an elevation of 180 feet from 60 miles across Lake Michigan on a warm spring day with very calm, cold Lake Michigan water. It was ideal for setting up a temperature inversion, and as a result, Norwicki saw more of Chicago than would be expected from that elevation. Now notice that the Willis Tower is stretched vertically. So are these other buildings. There's some distortion. That's because in the atmosphere, it doesn't look like a magnifying glass, and it doesn't look like a Fresnel lens, which has a center and then radiates outward around that center. The atmosphere is thickest just above the lake level due to the cool air and the temperature inversion, and decreases in thickness as it goes up. The light is being bent around the curve of the Earth and is coming downward. Chicago is loomed up. And again, that's exactly what we're seeing. Notice there's no side-to-side distortion. It's all vertical distortion. And that is what you would expect with a temperature inversion. So, this is Bob the Science Guy signing out from Northern Michigan. Hit that little like and subscribe button down there. And hopefully, after looking at these 3 examples, you aren't going to fall for the parlor tricks masquerading as science that the Flat Earth tries to put forth as an ad hoc excuse or explanation for obvious signs of curvature. Take care, guys.